All right, so let's look at our first example here. What we need to do in all cases is always factor our denominator. So if we factor that denominator, what we have to think of is factors of 6 and 25. So 6, I might use a 2x and a 3x, and 25, maybe 5 and 5. So that gives me 6x squared, 15 plus 10, that's going to be 25x, plus 25. So that looks like the correct factorization. So now I can say, well, that's x over 2x plus 5 times 3x plus 5. And these are different terms as far as factors, they're not quadratics. And so that's just going to give us a over 2x plus 5 plus b over 3x plus 5. Okay. Now we multiply by the LCD, 2x plus 5, 3x plus 5. When we multiply the first one, we just get x. And multiply the next one, 2x plus 5's cancel, so we'll have a times 3x plus 5. And then here we have plus b times, now the 3x plus 5's cancel, and we have 2x plus 5. Now distributing on the right, we get 3ax plus 5a plus 2bx plus 5b. So we have x, x, and x. There's nothing here, so that's going to be a 0, and those are going to be set equal to 0. So it's going to be 0 equals 5a plus 5b. And then here we have 1 equals, now we have 3a plus, 2b. All right, so what do we want to do? Well, I think the b's are going to have us multiplying by smaller numbers. So if I multiply this by maybe 5, and this one times a negative 2, that will allow me to get rid of the b factors. So then I have 2 times, or negative 2 times 0 is 0 equals negative 10a, and then minus 10b. On the denominator or bottom part here, we have 5 times 1 is 5 equals, now 5 times 3 is 15a minus 10b. And so now those, let's be a plus, those cancel. Now 0 plus 5 is 5, 10 plus 15, when that's a negative, is going to give us 5a, divide by 5, so a equals 1. So if a is equal to 1, we have 1 equals 3, basically times 1 is 3, plus 2b minus 3, and so minus 2 equals a 2b, so b equals a negative 1. So our fraction decomposed is going to be a, which is 1 over 2x plus 5, plus b, which was the negative 1, over 3x plus 5. And so then that is going to be this fraction decomposed into the two fractions that were added together to get to it. All right. Next one. All right, so now it looks like we have to go ahead and factor our denominator again. So that one's a pretty easy one. It looks like x plus 5 and x plus 3. That's going to give us 5x plus 3x, 8x, and 3 times 5 is 15, so that looks good. So we have 4x plus 3 over the quantity x plus 5 times x plus 3. Okay, so this is like the last one. We have two different terms. They're non-repeating, and so we're just going to have a over x plus 5 plus b over x plus 3. All right, so what do? Well, we do like we have done before. We multiply by the LCD. X plus 5, x plus 3. So when we multiply by the first one, we just get 4x plus 3 equals, now the x plus 5's cancel, we have a times x plus 3 plus, now we have b times x plus 5 because our x plus 3's cancel. And now we simplify on the right, so that gives us 4x plus 3 equals ax plus 3a plus bx plus 5b. So we have x, x, and x, and then we have number, number, and number. And so we say, well, 4 equals, now we just have a plus b, and here we can say 3 equals, and that's going to give us 3a plus 5b. All right. Now let's say if we multiply this by a -3, that'll get rid of the a's. That's smaller than multiplying by 5. So when we do that, that's going to give us a -12 equals -3a, and then -3b, and this still stays 3 equals 3a plus 5b. So those cancel. Here at -12 plus 3 is going to be -9. And 5 minus 3 is 2b. So b equals a -9/2. All right. So not necessarily the nicest thing because we have fractions, but that's sometimes how it works. So now let's solve it, put it back in the first one. So 4 equals a plus a -9/2. So if we add 9/2 to both sides, well, 4, it doesn't have fractions, so I have to multiply that by 2 over 2. So that's going to be 8 plus 9, so that's going to be 17/2 is equal to then a. All right, so if we do that, 17/2 is going to be the numerator, so 17/2 over x plus 5 plus b, which was a -9/2 over x plus 3. Now, we could maybe simplify this and say, well, this is also the same as 17 over 2 times x plus 5 plus, now we have a -9 over 2 times x plus 3. So that might be a way to simplify it. That way we don't have fractions in the numerator. If they want us to have fractions in the numerator, then we can leave it that way. This is another way we can do it as well. All right. This one looks like we have it factored probably already, maybe x squared, maybe not. It looks like we can factor that denominator because we have an x squared, but this, I think, if we take that and say x plus 6 times x plus 6, that's going to give us 12x, 36. Yeah, so this is really what we have, or x squared times x plus 6, the quantity squared. Okay, so we've got quadratics with repeating fractions. So what we have to do is we have to do x cubed minus 5x squared plus 12x plus 144 all over x squared times x plus 6, the quantity squared, equals. Now we're going to have two sets of factors that are repeating. The x's are repeating and the x plus 6's are repeating. So what we have to do is we have to do a over x, then plus b over x squared, plus, now we have c over x plus 6, plus d over x plus 6 quantity squared. Okay, so we have a lot more terms here because we have the x is repeating and the x plus 6 is repeating. So this is kind of one of those special cases. And so that's x to the 6th, x plus 6 squared. So multiplying that out, we get our first term the same, x cubed minus 5x squared plus 12x plus 144 equals. Now when we take x and cancel that, we still have a times x plus 6, the quantity squared. Okay, then we have plus b times, well, the x squareds cancel, so then it's just x plus 6, the quantity squared. All right, plus c times, well, 1x plus 6 is gone, but we still have x squared times x plus 6. Plus d times, well, when the x plus 6 squared cancel, we have x squared. And so that looks to be what we have. Now we have to simplify. So now remember, x plus 6, the quantity squared, is equal to that. And so that's what this piece here is. And let's go ahead and put our first parentheses there. It looks like we dropped that. So that's what it's going to be here, plus that's what it's going to be here. And so we just have ax times that. So if we keep our left side the same one last time, minus 5x squared plus 12x plus 144 equals, now ax times what's in here, that's going to give us ax to the third plus 12ax squared plus 36ax. And then we have b times just that. So we have plus bx squared plus 12bx plus 36b. Okay, so we have b's now, and now c's. Now when we do that, we have x squared times that, so it's going to be plus cx cubed, and then we multiply that, that's going to be plus 6cx squared, and then we have plus dx squared. Now hopefully we have all of everything in here. So now we have to look. We have an x cubed, we have an x cubed, we have an x cubed. I think that's all the x cubes. Now we have an x squared, we have an x squared, x squared, x squared, x squared. All right, maybe we should start writing these down. So 1 equals, then we have a plus c, and here we have a minus 5 equals, then we have a 12a plus b plus 6c plus d. Okay. And then we have our x's, and we have our x's, and we have our x's, and I think that's all. So we have a 12 equals 36a, and then, okay. There we go. 36a, and where else were we at? 12b, and that was all. And then we have left the blanks, which is 144 equals, and over here, 36b. Okay. All right, so looks like we can solve for b first. So we divide both sides by 36. So b is equal to 4. Okay, so we got b. Now we can go back in this one and solve for a. So 12 equals 36a plus 12 times 4. So that's 48. So if we subtract 48, so we divide there, and then we have a minus 36 equals 36a. So a equals -1. Okay, so that looks good, I think. And now we can go back in, and we know a, so let's solve for c. So now we have 1 equals a minus 1 plus c, so add 1. So 2 is equal to c. So now we know a, b, and c, so now we can solve for d. So we have a minus 5 equals 12 times a, so it's a minus 12, plus b, which is 4, plus 6 times c, well, c is 2, so that's plus 12, plus d. Well, those 12s cancel, so we're going to subtract 4. So d equals, it looks like, a -9. Okay, so now we have D, C, A, and B. So now we have all those pieces. And I don't have enough space on that page, so let's see if we can get it all up the top. So A was, let's kind of block it off here. Hopefully we can get it all in there. So A was -1, so we have a -1 over x plus B, which we said was 4 over x squared, plus c, which we said was a 2 over, and that was x plus 6, and then plus d, so that's a -9 over x plus 6, the quantity squared. So that then is what this fraction decomposes into, 4 different fractions. Okay. So that one's probably the most complex one we've actually seen up to this point, just because we had a lot more things to work with. We had to realize that was x times x, which is, 2 of them. So we had to split that a piece apart. And this was x plus 6, the quantity squared. So we had those two we had to split apart. And then with those four, we got the four equations. And with four unknowns, and we had to simplify from there. All right. Let's see here. What do we have now? Now we have, it looks like the difference of cubes. We have an x cubed minus 125. So what we have is x cubed minus 125. Now remember, 125, that's going to be 5 times 5 times 5. And so that's going to be x cubed minus 5 cubed. And because it's the minus, it's going to be x minus 5 times x squared plus 5x plus 25. Okay. And so that will be what we break this down into. And when we finish that, what we have to do is put the original numerator over that. So that's going to give us x squared plus 2x plus 40 over x minus 5 times x squared plus 5x plus 25. And so these are non-repeating irreducible quadratics. And so what we have to do is we have to put a over the first term, which is the non-quadratic, plus bx plus c over the next term, and since we only have one of those, we just have the x squared plus 5x plus 25. And then from there we can simplify by just multiplying again both sides by the LCD, which is what our original factoring was. So multiplying it there, we get just x squared plus 2x plus 40 equals. Now the x minus 5's cancel, so we have a times x squared plus 5x plus 25. And then plus, and then those cancel, so we have bx plus c times x minus 5. Then we have to simplify the right side by multiplying out. So that's just ax squared plus 5ax plus 25a plus, now we have this FOIL, so it's bx squared, and then outer minus 5bx, inner is plus cx, and the last is minus 5c. All right, so x squared, x squared, x squared, then we have x, x, and then the numbers only. So if we look at x squareds, we have 1 equals a plus b. Okay, now here we have 2 equals, and we have 5a minus 5b plus c. And then the next one we have 40 equals 25a minus 5c. All right, so hopefully I have all of that right now. And now what I'm going to do maybe is if I take, and what would be the best way to go here? If I have this plus this, if I multiply it, we have A and C there. So I think I want to get rid of the A's, maybe B's. I don't know what the easiest way is going to be. So let's just take and multiply this times 5. Maybe let's start with that. And that's 5 equals 5a plus 5b. If we add that to the second equation, 2 equals 5a minus 5b plus c. The b's cancel, then that gives me 7 equals 10a plus c. Now I've got these two with a's and c's only, and so if I multiply this one times a 5, that will get rid of c's. So then I have a 40 equals 25a minus 5c. Here I have 5 times 7 is 35 equals 5 times that, it's still going to be 50a, and then plus 5c. So those are gone. So 40 and 35 is going to give me 75 equals, and here that's going to give me 75a. So a equals 1. All right, so if a equals 1, I can go and get b and c pretty easily. So if a is 1, 1 equals 1 plus b. Subtract 1. b equals 0. And so c, if I do that, then if I have 40 equals 25 times 1 is that, minus 5c, and minus 25. So that's a minus 5c here. That's going to be a 15. So c equals a negative 3. Okay. And so now I've got A, B, and C, so I can plug that back into this. So A is 1, so I have my final answer in the decomposition is going to be 1 over x minus 5 plus B, which we said was 0, then C was minus 3, so minus 3 over x squared plus 5x plus 25. And that should then be my answer as far as the decomposition of this fraction. And again, this one, we had to realize that that was the difference of cubes. All right, so another one. All right, so this one, it looks like it's been factored for us. So we really don't have to worry about factoring. We've got two quadratics that are repeating and they're non-reducible. And so when we did that one, if you remember, that was going to give us the ax plus b over first one, x squared plus 2x plus 9, plus, and then we had cx plus d over the thing squared. And then that should give us our original formula we need to solve. And so now we multiply by the LCD. 2x plus 9, the quantity squared. So then that gives us x cubed plus 2x squared plus 4x equals. Now, one of those cancels one of those. We have ax plus b times x squared plus 2x plus 9. And then plus, those cancel, so we just have cx plus d. Now we're going to have to distribute everywhere there, so that gives us x cubed plus 2x squared plus 4x equals. Now that's going to give us ax cubed. Then ax times that's going to give us plus 2ax squared, and that's going to be plus 9ax, plus, and then we have bx squared, plus 2bx, plus 9b, plus our cx plus d. All right, so we've got 1x cubed, so we have 1 is equal to a. So we've got that already. Now we've got x squared, we've got x squared, we've got x squared. And so it looks like 2 equals 2a plus b. All right, then we have x's, and we have x's, and we have x's, and we have x's. So that says that 4 equals, and that was going to be 9a plus 2b plus c. And then we have 0 equals, and then we go all the way across, and we have 9b plus d. So 9b plus d. All right, so now we can plug in 1 here, and we get 2 equals 2 plus b, subtract 2, b equals 0. Well, if b equals 0 here, then d is equal to 0 also. So that was quick. And now we just have to solve for c. And so 4 equals 9 times 1, which is 9, plus 2 times b, which was 0, and then plus c, so minus 9. And so c equals a minus 5. Okay, so we got C, we've got B, we've got D, we've got A. So now we can plug it into the original up here. We even have room down here to do that. So A, we said was 1, so that's just going to be x plus B, which was 0. So it's x over x squared plus 2x plus 9, plus C, which was a negative 5x. D was 0, so that's a 0. And then we have x squared plus 2x plus 9, the quantity squared. And then that should then be our original fraction decomposed into two fractions. So that's a few more exercises to kind of show you some more examples of how to decompose fractions.